Hi guys, I'm back with notes for continue. We're going to do some more problems now where you not only combine the areas, sometimes you have to subtract areas. So our first example, remember the thing about these are they're not drawn to scale. And we're going to use 3.14 for all our calculations for pi. Okay, so our first example is this shape. It has like a rectangular bottom. And at the top, it's been cut out in a circular shape. Okay, so you can imagine this is a semicircle. This is half a circle that's been cut out. From the top down to the bottom, it's 15 centimeters. And the bottom, 10 centimeters. Okay, so we want to imagine this thing was once a rectangle, and they've scooped out part of it for this circle. Okay, so we're going to start with a rectangle, and then we're going to minus the semicircle area. Okay, the ones that we did before we added, now we're going to subtract because there's something missing here. Okay, so when we start with a rectangle, we can do length and width or base and height. I think base and height makes more sense to this. The base would be 10, the height would be 15, which would be 150. Okay, now that is the area if this was not missing. Okay, if it was a full rectangle, we would say the area is 150, be done. Okay, but because we had this shape that's missing out of it, okay, all we're really finding the area of is this shaded part. We have a part missing at the top. So we want to do half a circle subtracted off this rectangular area. So we need to know what would the radius be. Okay, well, if the total length across is 10, that would represent the same as the diameter. So the radius would be half of that, which would be 5. Okay, for a circle, it's power squared, but we're going to do 1/2 power squared because we're doing a semicircle. It's half a circle. 1/2, or we use 3.14. The radius is 5. Okay, and then we'll just calculate that. Double check. So 1/2, 3.14 times 5 squared, 39.25. Okay, so then when we find the total, this time we're subtracting 150 minus 39.25. 110.75. Okay, so not all the time are you adding to find the total. Sometimes there's parts missing and you have to subtract. The next example, I have a large square. Okay, and in the middle, they have a smaller square that has been subtracted away. Okay, so remember, these are not drawn to scale, just freehanding. Okay, so the original square had a length of 20 centimeters, and that's equal on all sides, so I'll put the tick marks to show it's equal. Right, and then we want to just find the area of the original shape minus the square shape in the middle. It almost looks like a donut with the square taken out. Okay, so on this shape in the middle, they're giving us 5 centimeters for all its sides. So I'll put double tick marks all the way around. It's a square with 5 centimeters. Okay, so we're going to do the big square. And we're going to minus the small square. That's our plan. So area is base times height or side squared since it is a square. Okay, we'll be subtracting the area of the small square. Okay, its side squared is 5. 5 squared is 25. Okay, so then the total is going to be 400 minus 25, which is 375 centimeters squared. Okay, my last example I want to show you, it's a little bit hard to visualize, but it's a square. Okay, and inside the square sits 4 circles that have been cut out. Okay, and I know I don't have the perfect freehanding ability here. Okay, but imagine it is a square. It's cutting out 4 circles that are all congruent. Okay, so all we're finding the area of is this little bit of overlapping where those circles don't cover. Okay, so we're given a square with 4 congruent circles. Okay, the sides of the square are 15 inches both ways. Okay, so we have to do the area of the square. So we're going to do the large square. And we're going to minus 4 congruent circles. We're going to subtract those away from the large square. Okay, well, the square is going to be easy, side squared. So that's just going to be 15 squared, which is 225 inches squared. And then we're going to subtract these 4 circles. Okay, well, circles are pi r squared, so there's 4 of them, so we're going to do 4 pi r squared. Okay, what we need to know, though, is what is the radius? Okay, it takes 2 radiuses to get to the center here. Okay, as well as over here. It takes 2 radiuses, which forms a diameter to get to the center. So if we think about half in this, 15, half of 15 is 7.5. 15 divided by 2 is 7.5. So if we take half of that, that should give us our radius, 3.75. Okay, and we can check that. 1, 2, 3, 4. If I do 3.75 times 4, I get back the original 15. Okay, so once again, to find the radius, I took half of 15 for this circle, which is 7.5. Then I took half of it, which is 3.75. So that's what the radius represents for each one of these circles. Each one has a radius of 3.75. So now we're going to go ahead and do this formula. There's 4 circles. We're using 3.14. The radius is 3.75. We want to square that. So we'll go ahead and type that in. 4 times pi, 3.14, times our radius, which is 3.75 squared. 176.625. I'm not going to do any rounding right now. I'm just going to go ahead and subtract these 2, then we can round. 225, which was the big square, minus the big area of all those circles, 4 of them, 48.37. So I'm going to round to 48.38 inches squared. Okay, that concludes our subtraction notes. So I first gave you some examples where you had to add. Now you've got some examples where you got to subtract. So I hope this helps, and I'll add another video on subtraction so that you can view that as well if you need extra help. And that will be the same video that Foundations is watching. So have a good day, guys. Hope this helps. Bye.